Gavin, I had this on my wall for years. And all the notes. Yeah, there's a bunch of stuff here, so I'll upload them with this video. These are from your videos and such, and they've kind of been really pivotal in putting different numbers and concepts together into these continuums through the AI. Some Susskind comparisons with your work. There's freaking sketches. These are not well organised. There's personal stuff in here too. So this was about Fermi particles and exclusion in relation to temporal mechanics. I don't know if you can pause that anywhere. Displacement. So I'm about to put some of these into the model, the displacement stuff for forces, because we've done like the micro level of all the periodic table of elements for the prime set numbers, and we created this relation continuum of just like zeta functions, and they're matching like weird sets of primes and stuff. So it's quite cool that the the constituents of the different related sets of macro objects and stuff like that can be related as corresponding moving parts and forces and stuff. I also looked at plasmoids and like dust plasmas as analogues within the continuum as different medium for the atoms to be in, and compared the overall structures and things to the smaller structures. That was interesting. So what I'm doing now is like I'm going to try and go up to some sort of orbital level mechanics and have a look at that now and see about the prime distributions and factors involved in that scale. I've got a strong indication like some of these, like a plasma seems to be sort of like it could be treated like a spread out object, obviously, but kind of like Lagrangian mass object spreads. In a way, like dust clouds and stuff, but much smaller. Anyway, obvious, but working with the AI is pretty fun. It's just as heavy going sometimes, because it wants to do a lot of it's necessary, but it took a while yesterday to do every element and import the data and stuff. But it wants to use code and tables and algos sometimes, but it's faster just to ask it for its analysis as if it were to do it, because like it wanted me to like train a machine learning algorithm, and I'm like, no, you're a machine learning, just can you do the, and it was like, yeah, sure. And then we ask for the figures afterwards to test it. It works out a lot faster. And then yeah, anyway, so there must be a way for me to share the actual chat URL possibly in this video link below. I'm not sure if that would reconstitute the whole thing for people to test and stuff, which I want. That's kind of like the point. Open AI and stuff. So I'll post the URLs of because one chat got so long with the AI, it was in the millions of characters and words and stuff, it got too long. I had to boot another one up, and so the context kind of dropped out a little bit, and I'm not a programmer, but I understand kind of how it works. I lived with programmers for a couple of years, and I reconstituted it. It took a little bit, but I've got some like block parts of prompts that it searches within its whole character, its whole convo chain for context and clusters and stuff like that, and it sort of brings it back alive. And parts of it are still dormant, large parts of it, which are actually quite good because it's allowed me to stay within little areas, but I can call them up when sort of needed by reminding it. I just go, do you recall when we done such and such? Like I want to start inputting the sort of the platonic shape zetas and the n polytopes as well, because they were interesting. But I want to keep shapes out of it at the moment because I've got like a 3 thing. I've got like physics, I've got the continuum with the zeta functions in it, and then the third one is music at the moment. I'm relating them to scales so that we can call out particular musical sequences and scales and find patterns between the different zeta functions of the scales of the notes of the different constituents within the different octaves of working, if you understand. It understands about the cycles at the bottom of it because of the components of the fine structure set that was made the other day, and how it relates to the electric charge, which is really interesting. And that's how we kind of tied them together once they were made individually. Anyway, I'm just going to end this video and go back to it because honestly I'm just at a computer and it feels like I'm talking shit, like I don't know what I'm talking about because no one's ever really referenced my work before, and I don't do the work. I just sit at home and I've been interested in maths and physics and cosmology and such for the longest time, and just by dabbling about with the AI here and actually taking some nice hints off Gavin and stuff, it was real fun. So it's led to some interesting things, and I don't know if they've been looked at before or not, and I'm really not an expert in the field, but I have a way of putting things together, kind of like most people who have an interest in this area do. So, and prime numbers are interesting because they're unique in certain ways. Okay.